Section 5.1 is zero and negative exponents. Our goal is to interpret expressions in terms of its context. On page 283, we have the patterns you found in the Solve It illustrate the definitions of zero and negative exponents. You can extend the idea of exponents to include zero and negative exponents. Consider 3 cubed, 3 squared, and 3 to the first. Decreasing exponents by 1 is the same as dividing by 3. If you continue the pattern, 3 to the 0 equals 1, and 3 to the negative 1 equals 1 over 3. For every non-zero number a to the 0 equals 1. For example, 4 to the 0 is 1, negative 3 to the 0 is 1, 5.14 to the 0 power is 1. For every non-zero number a and integer n, a to the negative n is equal to 1 over a to the nth power. For example, 7 to the negative 3 equals 1 over 7 to the third. Negative 5 to the negative 2 power is equal to 1 over negative 5 all squared. Why can't you use 0 as a base with a zero exponent? The first property above implies the following patterns. 3 to the 0 equals 1, 2 to the 0 equals 1, 1 to the 0 equals 1, and 0 to the 0 would equal 1. However, consider the following pattern. 0 cubed is 0, 0 squared is 0, 0 to the first is 0, and 0 to the 0 power is 0. It is not possible for 0 to the 0 power to equal both 1 and 0, therefore 0 to the 0 is undefined. Why can't you use 0 as a base with a negative exponent? Using 0 as a base with a negative exponent will result in the division by 0, which is also undefined. In example 1, it says, what is the simplified form of each expression? For part A, we have 9 to the negative 2 power, and part B is the quantity negative 3.6 to the 0 power. If we have a negative exponent, we were told that we can move the 9 to the denominator, and then the exponent becomes positive. Since we have nothing on top aside from the 9 to the negative 2, we can place a 1 there, and now we have 9 squared on the bottom. This middle step right here is optional. If you know right away 9 squared is 81, you can just skip this middle piece, but I did want to write it out just as a reminder that squared means you multiply by that number twice. So 9 times 9 gives us 1 over 81. If you have something else in your numerator, so for example, maybe we had an x, maybe we have 9 to the negative 2 power times x, you would keep your x up top and just move whatever has the negative exponent down. So for future reference, you're only going to move down the base that has the negative exponent. Over in part B, our previous slide told us any number aside from 0 raised to the 0 power is just 1. So it doesn't really matter what's in here. We have negative 3.6, but it could be anything other than 0, and this all will become 1. So anytime you see the 0 power, as long as this number right here is not 0, you can just write 1 and you're done. The work for part A is on the next slide. And then part B, we have some reminders. And now I would like you to try number 1 and number 2 on page 284 as your first U-tries. So simplify each expression. We have 1 over 2 to the 0 power and 1.5 to the negative second power. Now this one's already in a fraction. That doesn't change anything. Just remember what happens if you have a number to the 0 power. And right here we have a decimal, 1.5 to the negative 2. It might be helpful if you rewrite this as a fraction, and you can use 3 over 2. So if it helps you to write it at 3 over 2 all to the negative second power, you may write it that way as well.